In the second video on quadratic inequalities for finite math, we will look at a quadratic that is not already factored. Now it will be set to 0 like the example we did in the first video, but it won't be factored. Here's what that first example looked like. If you didn't already watch that video, you might start with that video because that might help you get the first step to understanding. But here's another example, because some of the examples, and I'd say most of the examples we see in finite math, are going to look like this, where it's a quadratic that isn't factored. Now, when you get a quadratic inequality and it's not already set to 0, you have to think of it like a quadratic equation, and that, hey, what we would do first is we'd set that to 0, right? So we'd add or subtract some terms to move everything off to the left side so that we have it set with the inequality set to 0. The next step is we're going to factor this inequality. And I'm not going to spend a lot of time on reviewing the factoring. There are other videos if you do need to catch up a review on factoring. But then once we have it factored, we have it set x minus 5 times x minus 3 is less or equal to 0. The next step is to find the critical numbers. The critical numbers are the numbers that make this equal to 0. So you'll notice that if x equals 5 or if x equals 3, we'd have this quadratic equation equal to 0. So those are called our critical numbers. After we have the critical numbers, we plot them on a number line. And let me say that there are other ways to solve a quadratic inequality. I worry that some students just skip all the steps and kind of guess and check. I'd encourage you that if you don't understand whatever process you've been using, if you've just been guessing, kind of rambling in the dark at getting this, then try this process so that you really understand what you're doing. Because what we've done is we've put out a number line and see that there's 3 regions. When we plot those 2 critical numbers, the 3 and the 5, we see that we get 3 regions here. And when we have those 3 regions, we can see that we're going to have to test 3 different numbers and see whether it's positive or negative. Now, to start with, because this says or equal to, I'm going to put a solid line here for each of those critical numbers. If you watched the last video, then you saw that it was a broken line because it was less than, so these numbers weren't included. But I know already that if x equaled 3, our inequality would be true, or if x equaled 5, our inequality would be true. But we've got to see what happens on these 3 intervals. So to test these 3 intervals, I put in a test number. I could put any number between negative infinity and 3, but because 0 falls in that interval, I'm going to use 0. Now I'm limited here with the 3 to 5. Well, not really limited. There's an infinite number of numbers I could use, but we don't want to be bothering with fractions, right? I mean, I could use 3 and 1/2, that's in the interval, or 3.000001, and that's in the interval. But I might as well keep it easy and pick a nice, easier number to use, like 4. But for my example, what I'm going to do, just for this demonstration, because I want you to see something here, is I'm going to use a number that's just one smidgen past. So really, I should have written it over here. Just one smidgen past that 3. So let's see what happens when our test number is just a smidgen past that 3, right? Just tiny, tiny, tiny increment to the right, but it's on that interval. Now, when you do these examples, make it easy for yourself. Just use the 4, but I want to show you what happens here. And then for the number that I'm picking that's somewhere between 5 and infinity, I'm going to just use a 100. And let's see what happens. So let's see what happens on each of these intervals. If I replace the x with a 0, I get 0 minus 5, which is negative 5. I don't really care what the value precisely is. I really just care if it's positive or negative. And then a 0 minus 3 is going to be another negative. And when I multiply a negative times a negative, I get a positive. What happens with this next interval? 3.00001 minus 5 is going to be negative. And just a tiny, tiny, tiny increment to the right of 3, so it's just slightly bigger than 3. When I subtract 3, I'm going to get a positive, right? Do you see that? Any number on this interval is going to be above 3. So any number on this interval, when I subtract 3 from it, it's going to come out positive. And then with the 100, 100 minus 5 is positive, 100 minus 3 is positive. And when I multiply those, I get positive. Oh, and going back here to the middle interval, when I multiply a negative times a positive, I get a negative. So let's see which of these regions satisfies our inequality, which is less than 0. The only one that turns out less than 0 is that middle one, right? The negative, because we had a negative times a positive, turns out less than 0. And then the positive intervals do not. So it looks like our solution, if I were to put this on the number line, if I were to highlight it on a number line, would go from positive 3, would go from positive 3 up to positive 5. So in interval notation, once we have that number line drawn, the answer in interval notation is really easy. It'd go from 3 to 5. But if you had been working this some other way, then you might have it written in this form, that x is less than or equal to 5, and at the same time, x is greater or equal to 3. Or reading this from left to right, we'd have 3 is less than or equal to x is less than or equal to 5. But that's the solution. If we're asked to put it in interval notation, then this 3 to 5. Oh, do you see the mistake I made when I wrote that? Glad I caught that before I ended the video. What I should have here is brackets around the 3 and 5. Do you see why I've got brackets there? Because we've got a or equal to. Whenever it's or equal to, that translates to a bracket. Do you see the easy way to see that? This or equal to part of the bracket, that nice horizontal line. You want a nice horizontal line in your bracket. So not a parenthesis, but a bracket. And that tells us that the 3 is included, the 5 is included. That wraps up this example. If you needed a little bit more help with this, you might try the first video where we started with a quadratic that was already factored, or you might look at some of the other videos on this topic in the pre-calculus videos that I have on YouTube. Hope that this helped, but if you have further questions, please don't hesitate to reach out to me.